And I want to go through it together and just make sure that we're all getting this graph thing going. So I snuck some old stuff. What's the front page? I snuck some old stuff on here, things that I remembered. Thank you. Things that I remembered. Missing on other quizzes. So this is one of them. This was a big problem. It's going to be worth a lot of points. And we need to factor it. There is no sophisticated factoring in this course. It's all very straightforward factoring by grouping, or the difference of squares, right? So I'm factoring as I'm going. Is everybody with me here? Everybody can do this. So up there I have a common factor. And then I have the difference of squares again. And then I notice that I have a cancellation. So after factoring completely, it looks like I am left with this. What do you think? Is that okay? That's what you got. Good. So now I'm going to have to start listing and drawing all of this stuff. So you need all the discontinuities. So you need all the asymptotes and holes, and then you need all of the intercepts. All right, so where do you want to start? Doesn't matter, we just need to get it all. So, okay, where do I have asymptotes?
Vertical asymptote at x equals -3.
I have a vertical asymptote at x equals -3. Right? Where do verticals come from? The denominator. They're called non-removable discontinuities. The x simply cannot ever be -3 in this problem. Okay. All right, what else do I have?
A slant asymptote.
I'm going to have a slant asymptote. Did you recognize that right from the very beginning of the problem when you saw the x cubed over the x squared? So to find the slant asymptote, I'm going to actually do this division. So that numerator is x squared minus 4. So I'm going to divide that by x plus 3. Now you can certainly use long division for this problem, or you can use synthetic division for this problem. I like synthetic with simple things like this. So I'm going to put a -3 out here in the box. That's what I'm dividing by. And then 1, 0, -4. Remember, gotta have that. Now, what does this quotient represent here? This represents x minus 3. This is the remainder, which in terms of slant asymptotes I don't care about. So my equation is y equals x minus 3. So I'm going to graph that. It's a line. Y-intercept is -3 and a slope of 1. So it's going to look like this. We were worried about you. Glad you're here. We're doing our review. All right, is that okay with everybody? All right, what else? Come on, what else goes into the picture? What?
You have a hole?
I have a hole. I have a hole because I canceled this guy out right here. So I'm going to have a hole where x equals 3 because that's the factor that I canceled out. So if I plug 3 in, and you can plug it in here, you can plug it in here, it really doesn't matter, plug it in somewhere. And it looks like if I plug in 3, I'm going to get 5/6. So in my graph at 3, 5/6, there's a hole. What?
You have an intercept at 2.
What kind of intercept at 2?
X-intercept.
An x-intercept at 2 and an x-intercept at -2. We're almost done. We need a y-intercept, and our y-intercept is going to be at -4/3. Okay, I got my asymptotes, I got my holes, I have my intercepts. I think I'm done. So now I'm going to connect the dots. And you really have a lot here, so you can really kind of see what's happening here. Would you agree with that? How does that look to everybody? Does that look good? Now, what I noticed on some of your papers was you were real good with the piece where you had points, like you're real good with that piece, but then some of you were trying to figure out where the other piece was. First of all, it's gotta be on the other side of the vertical asymptote. So you've already got the right side taken care of. It's the vertical asymptote that's the dividing line in the problem. So you've got it over here, now we gotta get it over here, okay? So your choices are on top of your slant or below your slant. That's it, you're on the left side over here. Okay, so tell me what you think. It's gotta be below, because if you put it up here, if you put it above the slant, it would have to cross the axis, and it can't. So this is your picture. All right? Is there anything about that anybody's got an issue with? Okay, let's get our calculators out then, and now we're gonna do a quadratic regression and answer some questions about it. So nobody is spectating, everybody is doing this. Was that Mrs. Bradshaw? All right, so we're going to stat edit, and we're going to put in some numbers here. I actually don't see her handwriting that often. So it says find a quadratic model for the data. Well, right there it is. That's the model that my calculator gave me. Does the model over or estimate at x equals 3? Well, if you have your regression column set up in your stat edit, you just have to see which one corresponds, which of those residuals corresponds with 3. Do you have one? You could also calculate it by hand, but your calculator does tell you what is the residual at 3. Negative point, I got 0.1429. Does the model over or underestimate at this point? Overestimates, because remember, the residual is actual minus predicted, so actual minus the model. And if that's a negative number, then isn't this bigger than that? So it overestimates. C, make a residual plot for this data. Okay, so you've got your residuals in the calculator, so we go to second stat plot. And if you're doing a residual plot, you have to have Y list in your stat plot menu. You have to have Y list as residual. If you do, then you ought to just be able to hit graph. You may have to zoom stat, but you ought to just be able to hit it and it's going to come up. All right, did everybody get it on your calculator? Okay, now we're going to actually reproduce that on our own. So if you want to go back to your list, you can absolutely do that. We're going to be plotting at -2, -1, 0, 1, 2, 3, and 4. We're going to be plotting residuals at those X values. You can get your Y values from the list, the residual list in stat edit, or you can hit trace and the calculator will tell you exactly what those Y values are. So at -2, it's 0.404. So let's make this, I don't know, 0.5 and 1. All right, so 0.404. And then if you just arrow, it'll tell you the next one is -0.4. And then arrow, and that one is -0.5. And then the next one is at 0.2. Again, you can certainly plot the points directly from your stat edit, your list. But here, we just do it. Everybody okay with that? Okay. Now it says find G of 5. And I want to make sure that you know how to do it both ways. What's one way of finding G of 5? Just plug in 5, right? Just plug it right in. Now, if you have already calculated the equation, you can also just go back to your home screen. You can also press vars, variables, vars, get y vars, function, and y1, just like we've done before. And then in parentheses, next to that y1, put 5. And it will give you the value plugged into the whole equation. Remember, I rounded it off when I wrote this down. So it will give you the actual unrounded version. So with that calculator technology, it's -27.571. Now, if you plug it in, you're actually plug in 5, you're gonna be very close to that, but you're probably not gonna be exact because we rounded these off. Okay?
You hit vars, y vars, function, y1, and
Uh-huh.
put in parentheses 5.
Yep.
It says error.
Okay, well, something's not right, I don't know. I'll deal with that later. Right now, we gotta do this review. So, did anybody plug it in yet? I did last night, and if I did it right, I got negative 27.575.
Yep.
Which is close. This is the better answer because it doesn't, have any round off involved in it, until I wrote down my answer. This depends on what the directions say. All right, and last one in this part, find x so that g of x is negative 100. So this time, we want this to be negative 100. Would you agree with that? So if I'm doing the problem, and I have my calculator, I'm gonna go ahead and graph my equation and graph y equals negative 100 and look where they intersect. All right, so let's try that. Now, we're definitely gonna have to make some window adjustments here. So I know my y's gotta go down past negative 100, so maybe negative 150. Just play around with your window until you see clearly this parabola opens down. You gotta see that. If you're gonna do the problem this way, you gotta see that, because you're gonna find these 2 points of intersection. This time, the data doesn't have any meaning, I just made up numbers. Be careful, because if it's like a real life problem, often the negative one you can't use, depending on what X stands for, but in this case, we need them both. So second intersect. Sander, what are you guys doing?
I'm still in the negative 100.
Okay, let's get it done. Joe, you need to do this.
That's fine.
Yes, indeed. All right, here's what I came up with. I'll wait for somebody to confirm this.
Yep.
What?
How do you get both lines to show up on the graph?
These both lines.
Like negative the 100, y equals negative the 100 in the parabola, because whenever I put it in,
Well, you should have 2 equations in your y equals. You should have the one from the data, and and then you should have, then you just type in a second equation and it'll come
Okay, yeah.
Okay, let's move on. If we have time at the end, I'm gonna give you, I have one more thing for you to work on. I can help with calculator stuff, but I wanna get through this sheet, so let's go. Number 3, true or false? We've been doing these since August. Let's see if we can get these right. Here we go. A of x is negative and concave up on the interval from -5 to -1. So locate the interval from -5 to -1. Is the function negative and concave up? Yes. When we say the function is negative, we mean it's under the x-axis. That's where functions are negative. And clearly it's concave up. All right, true, good. B, the rate of change of a of x is decreasing on the interval from 0 to 5. So find the interval from x's are 0 to 5. The rate of change is decreasing. What's your thought on that?
False, cause it's which is
Okay.
decreasing.
Okay, but we can't be true and false, Oscar.
No, I mean, like,
So
it's
what-
false because it's both.
Okay, because guys, if the rate of change is decreasing, what does that mean about the curve? It's concave down, right? Concave down. Now, from 0 to 1, 2, 3, I would agree that's concave down, but tell me about 3 to 5. That looks concave up. So that is a false statement, as Oscar pointed out. It's partially true. If it was 0 to 3, okay, but not the whole interval. So that's a false. All right, next one. A of x has a point of inflection at x equals -5. Would you agree with that? The picture goes from being concave down to concave up. Perfect, true. A of x is positive, and its rate of change is positive from 5 to 10. So 5 to 10. Tell me why that's false.
Because it's not always positive.
Because it's not always positive. It's negative from 5 to what, 8? Okay? Okay, good job. Okay, selected values of the continuous function are shown in the table above. Find the values in the table to answer the following. So, the function g has made some changes to f. So what changes have been made? What does this 3 do? Multiplies the y. What does this do? Left 2. So basically subtracts 2 from the x's, moves it left 2. And what does that do? Down 1. Perfect. So now we want to find g of 1. Well, according to the function, that's going to be 3. Now I'm putting in 1 for x. So this is going to be 3f of 3 minus 1. Well, what's f of 3? F of 3 is 5. 3 times 5 minus 1, did you get 14? Easy peasy. Find k if g of k is -7. So remember, this thing is g. So g of k is 3f of k plus 2 minus 1. But they tell me that g of k is -7. So would you agree with this?
Yeah.
All right, let's start solving. So let's add 1. divide by 3. And now's where you gotta get a little bit intuitive here. I don't know what this is, but f of it is supposed to be -2. So let's look at our chart. F of what is -2? 8. So this guy right here has to be 8 because f of 8 is -2. So k plus 2 has to be 8, which means k is 6. All right, B goes along with the same thing, same chart. D says we have a new function, p of x, that's going to take our f, our chart here, this is the f function, and it's going to do stuff to it. What's it going to do to it? A horizontal dilation by a factor of 3. That means you are multiplying the horizontal by 3. Which means what number is going to go inside this parentheses with this x here? No, 1/3. Guys, remember, that number, the coefficient on x, is a divider. And if you want to end up multiplying by 3, you're going to have to divide by 1/3. A reflection over the x-axis. Negative out here. And a vertical translation of -4. So there it is. This is what the p function does. So we need to find p of 3. So again, p of 3, that's x now. X is 3. So according to the model you just built, it's going to be -f of 1 minus 4. So what is f of 1? F of 1 is 7. So this is going to be -7 minus 4, -11. Find x so that p of x and f of x are equal. So p of x is this, and that has to equal f of x. Now, I do not have an equation for f of x. All I have for f of x is my chart. To use my chart. Are there any fractions in my chart? So does it make sense to you that whatever x is, it's going to have to be something that's divisible by 3? Because if I put a 1 in there, then I would need f of 1/3, and that's not possible in my chart. So I'm already going to just restrict myself to either using -3, 0. Yes?
On the interruption, can you please send Xander Carnahan to Student Services?
Yep.
Thank you.
Hurry back, Xander. 3 or 9? Is everybody kind of following what I'm talking about? Okay, so I narrowed it down, my answer is one of these, so since I have 9 at the top, I'm just gonna start with 9. If 9 is it, then what's this gonna say? It's gonna say f of 3 equals negative f of 9 minus 4. Can I check that? Yeah. What's f of 3? F of 3 is 5. What's negative f of 9? That would be 6 minus 4. Okay, well that didn't work. You see? So then let's move on to negative 3. So negative 3 would say, if I let x be negative 3, it will say f of negative 1 equals negative f of negative 3 minus 4. So what's f of negative 1? Negative 5. F of negative 3 would be f of negative 3 is 1, so negative 1. Oh, whoa. Did that work? I think that worked. So I had to find an x so that those two things match. I think the x that works is negative 3. Okay? All right, the graph is shown above 3 line segments, and now we're gonna graph the transformation. Most of you did really well with this in the homework, but there were a few of you that were kind of off base. So let's take a look at this. Oops, g of x is 1 minus f of 2x. All right, so here's what I'm gonna do. I'm gonna start, and you don't have to do it this way, but I'm gonna start with the original points on the graph. So the original points on the graph, main points, obviously I'm not doing all the points, are 1, 2, 3, 4, negative 4, negative 4, 0, 0, and 2, 2, and then 1, 2, 3, 4, 0, and 1, 2, 3, 4, 5, 6, 2. So those are kind of some main points on the original graph. Would everybody agree with that? Now I'm going to build my new T-chart. This is for F. Now I'm going to build it for G by doing the changes here that need to be done. So I'm going to turn this around. I don't know why that makes more sense to me. You can certainly leave it this way if you want. I'm going to turn it around and I'm going to talk about what's happening. What's happening to my x's? My x's are being divided by 2. So my x's are going to be negative 2, 0, 1, 2, and 3. Those are my new x's. Now what's happening to my y's? Two things are happening to my y's. First of all, they're getting made negative, and they are moving up 1. Raina? Did you ever? Am I missing something here? Okay, so I'm going to make my y negative and move it up 1. Okay, so that's going to be positive 4 plus 1, 5. Make it negative and add 1. Make it negative and add 1. Make it negative, add 1. Make it negative, add 1. Does that look okay? Now I'm going to plot those points on the same graph as this one. I'm going to plot these points, and that should be your answer. So go ahead and do it. See what it looks like. Yours is going to look better than mine because I don't have graph paper like you do. what you get should be the upside down squished version of the original. Is that okay? All right, got another set of data. Here we go. This is about cellular phone subscribers. So here we go. We're going to stat edit. I'm going to put these guys in. And then write a linear regression this time. Does that look okay to everybody? All right, what percent of the variation is explained by the model? That's R squared, R squared. So it's about 99.570%. This is a pretty good model, isn't it? Yeah. Find the residual for 2002. So again, you can calculate that by hand. You have the actual value. You can find the predicted value, and you can subtract. Or you can simply go to Stat Edit and go across to your residual column, and I need 2002. I got negative 2.139. What does that tell me? What does that number tell me? Well, we keep talking about this, but that's an important question. A negative residual means that your model overestimated. Draw a residual plot for the data. So again, your calculator will do that, but if you have to reproduce it on here, you can either get your values, since I have my list right here, I'm just going to use it, but you can certainly trace your residual plot if you have that on your calculator. So I've got what years there I have. Looks like my residuals. So the highest one. -2.2. shoot, I missed one at the top. Didn't get my first one, so negative 0.8. And then negative 2. There we go. And hopefully that looks like what the calculator shows. Is that okay with everybody? Alright, so you can get those residual values from the list or straight from your calculator by hitting trace, and it will tell you what all those are. Alright, last one. Here we go. What is the limit? I've drawn the picture there for you. What is the limit as x approaches infinity? -3. What's happening to the curve as you head toward positive infinity? Trace it with your pencil. Where's it going? Closer and closer to the asymptote. It's called an end behavior asymptote. It tells you what your end behavior is. It's horizontal. You're getting closer. It's like a ceiling. You're getting closer to it, right? I hope you all put -3. All right, next one. What's the limit as we approach our vertical asymptote from the left? Our vertical asymptote from the left, what's going on? Negative infinity. We're going down. What's the limit as we approach 3, which, oh, by the way, is where your hole is, right? What's the limit as you approach the hole from the left or the right? It doesn't matter. What's happening? What do you get closer to? Is it 6? I got 5, but it could be 6. I could have counted wrong. Is it 5? 5. What's the limit as x approaches negative infinity? Go this way. What's happening? Getting closer to -3. Now, if you want to be real specific, on the right side, we're approaching -3 from the top. And on the left side, we're approaching -3 from the bottom. And I still don't know yet how specific we're going to need to be, but you get that, right? Top or bottom. And then, what's the limit as we approach our vertical asymptote from the right side? Positive infinity. Yep. Okay? Now, I don't know when I see you again after break, but the first day I see you, we are going to review a little bit more with this sheet that I'm going to give you right now. And then the second day after that, we're going to have a quiz over this end part of the material, okay? Ms. Grieve and I have talked about this, and because these units are so massive, we're not going to have a test over Unit 1. Basically, now don't celebrate. Basically, your exam will be Unit 1, your semester exam will be Unit 1, and whatever we get through of Unit 2. But we plan to just continue every so often having a quiz, and then the exams will be the cumulative stuff. So, here's another review. This is over the whole unit, and it's kind of a fun activity that Mr. Passwater put together.
Everything and also all my college application and I do literally like and blood like one side that once I get all my college
Alright, so once you get started on this, and I don't know if you would rather, like, just on your own work on it or work with a partner. I really don't care, but I want everybody working on this. So everybody working on this. Finished it?
That was so confusing.
It will, because remember your exes are different than mine. So when you go to a
The vice president, my aunt and my mom, so that makes sense. And she said, I would get
it
it.
doesn't really matter
Because
because
he's
it's
in the job section.
no,
No, for like, he's in Wisconsin, if you don't set up your board and everything, all like day minutes, we look at it's just. I'm just gonna go there.
Yes, it's like
Okay, now, let's see, I have one more thing I need to do, we're almost out of time. Quinn Brady, to the board. The fate of your peers rests in your hands. I want you to sketch that for me. You can do this, you can do this. And coaching is allowed. So if you see him do something that isn't right, you are allowed to intervene.
This is light work.
Wait, so what is this?
This is gonna be a grade for you. So you have a vested